everything, yeah? I hope you're well. Today, what we are going to be doing is determining the equation of sine and cos graphs, okay? I just realized that I spelled this incorrectly. It's supposed to be determining, so apologies for that. So, I just wanted to highlight something to you guys. If you look across my page here, which is lagging really badly, you'll see that I have done quite a few videos. So please guys, if you have just clicked onto this video, go and check out the playlist and just see what other things I have done. Because it's all got to do with trig graphs. So I really want to equip you well for trig graphs. Okay, so if you are able, go ahead and go take a look at the playlist, and then yeah, watch as needed. It would be good to watch in chronological order as well. Okay, so let's have a look, guys. When determining, again, I spelled that wrong, sorry. When determining the equation of graphs, there are two notes or two pointers that I want to highlight to you guys. The first thing is understanding and knowing what the original or standard graph looks like. So, for instance, if I just had to draw a really rough sketch of a sine graph, we know that it starts at 0, 0. It goes up, down, and then it'll go there again. But we know that the height is 1, right? And then we know that the maximum height is 1, and the minimum or the trough or the lowest point is -1. Okay, that is very important to know when we are dealing with determining equations, because what is going to end up happening is you're going to say, okay, well, I know the original maximum height is +1, and now if it has moved up, then you will know how to compare. So that is why it's so important. Okay, and then the second thing, I kind of just mentioned it now, is using almost like it's like a technique or method where you look what is the highest point and the lowest point, which I'll highlight to us now. Okay, so let's jump right into it. The first question that we have over here, let me just maybe put number 1, is determine the equation of this graph over here. This graph over here, we need to determine the equation, and we can see that they've already given us, we know it's a sine graph, okay, and we can see that it has been shifted. All right, so we need to identify what this q is going to be. So what you end up doing is once again, you need to understand and remember what a rough sine graph looks like that's unaffected. So we know that it goes more or less like that. We know that the height, the maximum height is 1 over here. We should know that by now. And then the minimum value is going to be -1. So now what you do, guys, is you say, okay, in my original standard graph, without it being affected by anything, in inverted commas or in brackets q, we know that my high point is 1, and we know that my lowest point is -1 in the original untouched, just normal sine or sin graph. Now, what's happened then? What you must do is you must study the shifted graph, right? And you're going to study, well, what is my new height and what is my new, yeah, my new maximum height and my new lowest point. I could have used better words for that, but you know what I mean. So the shifted graph, the highest point is -1, and the lowest point is, you can see over here, it is -3. So let's see if there's a correlation between our highest and lowest point. Let me use a different color. Let's use blue. So if I go from 1 and I need to get to -1, I have -2, right? Ding, ding, ding. Alarm bell should be going off. And if I have -1 as my lowest point in my original, but then it has gone down and it has become -3, then again you can see that the highest point has shifted down 2 and the lowest point has shifted down 2. And you will actually be able to see that the more you do it, is that the original sine graph would have looked something, sorry, let me just do that a bit better. It would have looked something like this, okay, and you can see that it's actually moved down. It's moved down 2 spots. So that is a technique. Each point that you know of your original graph has moved down 2 units. So this is actually like a nice little technique that you can use to actually identify how it has been shifted. So with all of that, I wanted to say nonsense, but it's not nonsense. With all of that, those wise words being said, the answer, let me just make some space here. The answer for determining this equation is, the answer is it's y is equal to sin x, and it was shifted down 2. So this is the answer for this graph over here. Let's go ahead and answer the domain, range, period, and amplitude question over here. So what would the domain be? Well, again, it's from negative 360 all the way through to 360. So we're going to say x is the element of from and including negative 360 to 360. Range, well, range is going to be from my negative value, so it's -3 all the way up until -1. So this is going to look a bit ugly, but if my maximum value is there and my minimum value is here, this is my range. So it's from and including -3 up into -1. That is where the y values exist for that graph. So it's y, it's the element of bracket, it's going to be -3 and -1. It goes up until -1. The period always for a sine graph is 360 degrees in grade 10. And then the amplitude, remember I told you how to do it. Either there's a little cheat code, it's going to be 1 because it's whatever's in front of that, or you can calculate it with the formula I gave you, the maximum y value minus the minimum y value divided by 2. So the maximum y value is -1, then the minimum is -3, so it's -3 over 2. This becomes -1 plus 3, that becomes 2 over 2, which is 1. So we end up getting the same answer if you want to do it that way. Okay, guys, let's do one more example. My computer's going to lag because there's so much on the screen. So determine this equation. Once again, we need to know the general shape. So we know, I've just explained, it's going to go 1 and -1. So the original is 1, the height is 1, and the lowest point is -1. Now we want to know in our shifted graph what is the highest point. So it's going to be 3, and then the lowest point is going to be 1. So now we can see that it's actually gone up. So there will actually be a positive value. So let's go and investigate. So from going from 1 to 3, we are plusing 2. So there should be a plus sign there. So we're plusing 2, and then from -1 and we getting to +1, we are again obviously plusing 2. So that is the technique that we can use, and we can see that it has shifted up 2 units. So with all that being said, let's answer the question. The new or the formula or the equation, sorry, for this graph is y equals sine x, and we're going to say it has shifted up 2. So this is our answer over here. Right, let's go ahead and do the domain. So it's asking, where do the x values exist? Once again, it's from x is a value of belongs to from -360 and including it all the way up to 360. Okay, all the way through. The range, can you do the range? You can pause if you want to see if you know how to do the range. I'll do it now. So I know that the y belongs to or exists from from +1 all the way through to 3. So it's going to be from 1 and including 1, and then all the way through to 3. The period again is always 360 for sine graph in grade 10, and the amplitude again, you can use that little cheat code. It's the imaginary 1 there, 1 not 0, and then, or you can take the maximum y value. So it's 3 minus the minimum is 1 over 2. So we're still going to get 1 anyways. Okay, guys, with all that being said, that is how we determine equations. It can get a bit more tricky regarding if there's an amplitude involved, but for now, I just want to explain this technique on how to do that, on how to determine the equation. I'm also going to do one question on the cos in the next video.